and who is joining us, and people who are watching this later on the recording. Thank you so much for making time. And thank you to Matt and Ced for joining us as well. Tonight we are going to be talking about and discussing and debating the topic of, is the universe fine-tuned for life? And if you have never heard of this idea before, Fred Hoyle said someone has maybe monkeyed with the physics and fundamental sort of constants that are behind the universe that makes things like these beautiful butterflies, which you can see behind me, possible. And so that's the idea that we're going to be discussing. And joined with me, I have Matt and Ced, who are both scientists. And thank you so much for making time, preparing, and making time to be able to join. And I know you've put a lot of work into that. Matt is a physicist. He did his undergraduate at Oxford here and is now a DPhil student doing atomic and laser physics. And Cedric is an AI researcher. He did his undergraduate, his bachelor's in computer science and maths at Henderson State University, and then his master's in predictive modeling and computational complexity at UC San Diego. Thank you so much for joining us, both of you. I thought maybe each of you could give us one quick fun fact about yourself, or something you do outside of your studies, or something just so we can see you're real people too. Maybe Matt, do you want to go first?
Yes, when I'm not doing physics, I do feel like the lab eats up a lot of my time. But yeah, I'm very involved in my local church. I go along to Socratic Society and talk about interesting philosophical ideas. And I enjoy playing the guitar too, but probably not as well as I do my physics.
I like to surf, and I'm really big into writing and reading, and a bit of a fitness junkie as well. So decent amount of outdoor stuff and a decent amount of indoor stuff.
That's really awesome. Thank you so much, guys. So for those of you who are watching, the way this evening is going to work is we're going to have some introductory statements or presentations. Matt is going to be giving the proposition case, and he's going to be giving that for 15 minutes first. And then Ced will have 15 minutes, and then Matt's going to have a 10-minute rebuttal to that, and then Ced 10-minute rebuttal. And then we're going to go into a period of open discussion for 30 minutes. And I think that'll be a really interesting part to the evening. I'm looking forward to that. And then a 5-minute closing statement from each of Matt and Ced. And then last part, we're going to get you involved. We're going to have a Q&A. And as we're going through the evening, you can start to think of questions that you'd like to ask both Matt and Ced. And if you look at the description down below this video, there's a link to a Vvox. And if you click on that, you can type in your questions. Please make them short. The shorter they are, the more likely they are to be asked. And you can also upvote questions that you'd like to be asked. So that's what we can look forward to this evening. Matt, we're going to get started with you, if that's all right.
Yeah,
great. Looking forward to hearing what you have to tell us. Go ahead. Thank you so much.
Going to share my slideshow. Yeah, so what we're going to be discussing this evening is the universe fine-tuned for life? In analyzing this question, I think the way that it makes sense for us to start is by thinking, what are we really asking? What are we really looking at when we try and think about fine-tuning? And I think the big question that we're trying to get a handle on is, of all the possible ways that a physical universe could have been, is our universe what we would expect? So we could have many different possible laws of physics, many different models, many different grand unified theories to explain everything that we observe. And is our universe what we'd expect? Based on those theories. So the big problem with this is, I talked about grand unified theory. This is too difficult. This requires us to have already reached the end of all of our scientific processes, all of the end of our scientific investigations, and already be trying to work out what that tells us about the universe. So instead, we're going to try and answer a slightly smaller and simpler question based on the physics that we know at the moment, and trying to make some deductions from what we have already, from the reliable physical models that our science has produced. And so that question that we're going to ask is, of all the possible ways that the fundamental constants of the standard model could have been, is our universe what we would expect? The standard model is our current best model of the universe. It's not perfect. There are definitely some issues with it, but it stood the test of time. It's been rigorously and thoroughly examined and subjected to lots of different experimental tests, and it seems to work pretty well. So this question we can answer. We can answer whether there's fine-tuning involved, whether this is the type of universe, the type of constants that we have are what we would expect. And I think the resounding answer that I'm going to be arguing for is no, this is not at all what we would expect. And so I'm going to list a few different examples. I've got quite a few, so I might run out of time and have to move on to something else, but I'll try and get through as many of them as possible. So the first thing we're going to look at is the example of particle masses. So sorry, it's going to be lots of physics. Feel free to wave at me if I'm saying something that doesn't make sense. But to start with, we're going to look at the standard model in terms of the elementary particles that make up all of our matter. So this consists of quarks in the purple, leptons in green. These are all the massive particles. They make up everything that we see around us. And then we have the gluon, photon, Z boson, and W boson. These are bosons. They carry force. And then we have the Higgs particle, which the Higgs field is associated with giving these fundamental particles their mass. So one thing you might think is, wow, this is a lot of different particles. But when we look around us, actually everything that we see almost all the time is made up purely of neutrons, protons, and electrons. And that's only 3 of these particles here, the up quark, down quark, and the electron. They make up all of the particles that we see around us. Why is that? The universe has so much material to play with, and yet it seems to be only making a very limited number of things. The reason for that is that these particles are all very massive. And using Einstein's famous relation of E equals mc squared, if a particle has a lot of mass, then it can convert that mass into a lot of energy. In fact, much more energy than it has mass, given the c squared in the equation. And so that means that if we have one of these heavier particles, then it can very quickly decay into one of the lighter particles, like an up or down quark or an electron. And so we see that almost all of our all that we see around us is made out of these 3 particles, the up and down quarks and the electron. But how stable are these? So if all the rest of the particles decay so quickly, why are these 3 particles stable? And it turns out that in reality, they really aren't very stable. So if the mass of the down quark was increased by a factor of 3, then that would mean that neutrons aren't stable. So down quarks are what we have mainly in the neutron, 2 down quarks and 1 up quark. And so if these increased in mass, then that would mean that the neutron was too heavy, too massive, and it wouldn't be stable. And so it would decay almost instantaneously into protons. And this would mean that we would have a world where there was only hydrogen. This isn't a very exciting world. There's no complex structure. We think about whether life is possible. That's one question we can ask. But in this situation, chemistry isn't possible. All we have is 1 atom, hydrogen, a single proton orbited by an electron, and 1 chemical reaction, that hydrogen turning into H2. That's clearly not an interesting world. Clearly no life is possible. What about if we increase the mass of the up quark? So increasing that by a factor of 6 means that protons aren't stable. So we go in the other direction. Now we only have neutrons. And if you thought that the world of only hydrogen was bad, the world of only neutrons is much worse. Neutrons aren't electrically charged, and so you're not going to have any electrons orbiting them. So you won't have any chemistry, just an empty, barren world of neutrons. What about increasing the electron mass? Again, if the electron mass gets too high, then electrons will be absorbed by protons in the inverse of beta decay to produce neutrons. And again, you just end up in the same neutron world as before. And so then in this figure, I've plotted some of these values. This is in mega electron volts, the natural units we use when talking about particle masses. And we see that for all of this blue region, life is simply not possible. we would end up in a world purely of protons, no chemistry, in a world where there's no atoms at all, or a world where there's purely neutrons. And this comes from C.J. Hogan, his 2000 paper. And now you might be thinking, that's not great. We're clearly in a slightly tricky position, looking at how much blue there is here compared to the amount of white. But this actually is, these axes I chose here are random. I'm going to go from -10 to +10 mega electron volts. If we actually zoom out to the correct scale, we should be considering the range of, say, particles in the range that of masses that we know. So say the top quark is the heaviest quark that we know. And so let's scale it up to that size. And then we end up with this graph instead. So there's still a life-emitting region there in white. I don't know if you can see it. I imagine you probably can't, because at this scale, looking at the difference in scale between 10 and -10 versus between 150,000 and -150,000. Now, if you're trying to throw a dart and hit the white area in this region, you're very unlikely to hit accurately, which is a big problem. So that's particle physics. I think I'm going to have to go through the next ones very quickly. So next we have the Higgs field. You might have heard of the Higgs boson, which is known to give these fundamental particles mass based on this experimental data here. But the Higgs field can be excited to produce a particle, which is the Higgs boson, and that has a particular mass. But when we calculate what we expect this mass to be, it's very different to what actually is an experiment. And it's off by a factor of 10 to the 16. This is a massive number. These are not like numbers that you can play around with. This is like 16 decimal places. And so we need some way of cancelling off all of this extra mass. There must be some mechanism causing this reduction. But why is this reduction done so precisely, right, to 1 part in 10 to the 16? We don't know what the physical mechanism is, maybe supersymmetry, but why is it so precise? And if this value varied by a couple of orders of magnitude, then life would no longer be possible. It would be like varying the masses of the fundamental particles, which is devastating, as we saw in the previous graph. I think I'm going to skip over the 4 strengths. So the next one is the cosmological constant. We go from the very small to the very big. The cosmological constant governs the rate of expansion of the universe. You might have heard of dark energy. We don't really know what it is, but it's just that space is slowly expanding away from us, as we can see in this diagram here. So if the value of this were increased or decreased by a few order of magnitudes, then that would mean that the universe was either expanding much slower or much faster. And both of these end up being catastrophic for life. In this graph here, we see, I might turn on a laser pointer. You can see there's this curve at the bottom. And so this curve is the average distance between galaxies as related to the size of the universe. And if the cosmological constant wasn't large enough, then the universe would start expanding and then would instantly shrink and crush all into a tight ball held together completely by gravity. And then if we increase the cosmological constant too much, then we have the opposite problem. The rate of expansion of the universe increases so rapidly that all the particles are never interacting. We have a sea of hydrogen and helium that are so far apart that they can never interact, and we can never have anything even closely resembling life. The probability that the cosmological constant falls within a life-permitting range is very small. Given a uniform distribution over the Planck limits, so this is the Planck density, what we think is the boundary of this theory, the likelihood of a life-permitting value of the cosmological constant is at most 10 to the -90. Outside this range, there would be no structure at all in the universe. What I mean here is it's not just that the universe would slowly collapse in on itself or would slowly expand out to nothingness, but this is in 1 second. These limits were calculated. In 1 second, the universe is either back straight in a big crush or completely spread apart with nothing possible to happen, no structure. Then we have the problem of entropy. By definition, high entropy states are more likely. This is, essentially the idea of entropy in thermodynamics. It's based on more and less likely states. But our universe appears to be in a very low entropy state. So as this image vaguely shows, a very high entropy state would be a universe full of just purely of black holes. But that's not what we see at all. We see across the entire range of the observable universe, we see stars, very low entropy, emitting light, a very low entropy form of energy, stars, planets, galaxies, interesting structures. In fact, we don't see low entropy at all. We see we don't see high entropy at all. We see very, very low entropy. And so Penrose calculated the probability of this. Well, I won't go into the details of the calculation. You can ask me about that in the rebuttal, Ced, if you'd like to. But he calculated the probability as 10 to the 10 to the power of 123. This is an astronomically large number. Yeah, I won't try and explain that, but it's too large. We should be worried about this type of probability. And then another example is law changes, which I won't cover. So going back to the question, of all the possible ways that the fundamental constants of the standard models could have been, is our universe what we would expect? But there's one slight problem here. Expect given what worldview? So what if our worldview that we're bringing to the table is naturalism? What if that is the perspective we're approaching this question from? In that case, we should analyze the probabilities the same way as physicists do when they're experimentally determining the values of these constants. Trying to work out the values, do an experiment to determine the value of a particular constant is a common thing in physics, trying to determine, say, the electron mass, the mass of the Higgs boson, all of these types of things. And in these calculations, we have to assume some background probability distribution for what we think the values will be. These tend to be either a normal distribution or a uniform distribution. And based on these distributions, there's no expectation that the universe should be life permitting. Barnes calculates the probabilities of the constants taking the values they do to be 10 to the minus 136. This is too small, just to give you a sense of scale. How many people in the world? 10 to the minus 9. How many bacteria in the world? 10 to the 30. How many atoms in the world? 10 to the 52. We're getting closer, but we're going to have to scale up a bit. How many atoms in the universe? 10 to the 80. Still too small. What if every atom on Earth contained its own universe full of atoms, and each one of those atoms were creating their own universe inside themselves? Then we would expect one of those to produce a universe that was life permitting on naturalism. Multiverse, I'm going to skip through this in the interest of time. Theism, I think this is a good explanation. God, if he chose to, could create a universe suitable for life. And I think on Christianity, this is exactly what we would expect. In Christianity, the Lord is presented as a relational God. We see this in the Old Testament. He desires to dwell with his people in the tabernacle. And then in the New Testament, we see Jesus coming, the ultimate display of God's seeking relationship. And I've included this verse from Mark. We think that God is clearly powerful enough to create the universe however he wants. He can tune the dials in whatever way he likes. So it makes perfect sense that he would tune the dials suitable for life, especially since he is a God who desires life. Okay, and I'm going to leave it there.
Thank you so much, Matt. I'm sure we'll come back to more of those things that you had to leave out in the rebuttals and discussion later. Sid, do you want to take us away?
Yeah, absolutely. Thanks, Matt. That was very informing. Yours was a bit more technical than mine will be.
Apologies.
No worries. We're very different professions, but I think our audience may have a lot of questions for you at the end. I'm just going to go ahead and dive into mine. One, I'm super excited to be here tonight, or tonight for you guys, today for me. Let's just jump right in. The fine-tuning argument is exactly as Matt presented it to be. It's very compelling. And I think that if I was ever to change my mind in favor of a creator, it would likely be some permutation of this very argument that would do it. It's just too intellectually rigorous to completely ignore. And I think a lot of other agnostic atheists would probably agree with me on that. To dumb it down for the rest of us who aren't physicists, the argument itself is pretty simple. Matt presented it very technically. I'll present it as simply as possibly. It's pretty much, the argument suggests that the laws of nature are set with incredible precision, and that precision allows life to exist. And that if even one of those values that Matt just expressed, whether it be particle masses or any of the fundamental constants of the universe, if they were to increase or decrease even slightly, that life as we know it, or some physicists even think that life at all would not be able to exist, that it would be impossible to arise. And to be frank, I would agree with that. I think the universe does appear to be fine-tuned in that way, but I think appearances can be deceiving. So although I don't disagree with the fine-tuning argument altogether, I will be going over why it's not totally convincing for me. So to Christians and many other religions, this precision, it would feel like a fingerprint of intention, like rather than an accident, which is what other scientists, well, which is what secular scientists would deem it as. However, I think that if you look at the argument very closely, through a objective lens, and you're not applying a theistic worldview to it initially, it does collapse a little bit under scrutiny. I think it collapses in several ways, but for me, it collapses when you think about the unexplored possibilities, and when you think about probability claims that are being made that we don't necessarily have the data to necessarily assess. If we want to test whether fine-tuning really points to design, we first need to ask whether the phenomenon that's happening is even surprising in the first place. I think that's a very important question. When you think of surprise, obviously you're dealing with human psychology, which is something that we have to take into account when it comes to arguments such as this. Simply put, sometimes what feels miraculous from one perspective turns out to be inevitable from another. And I think a lot of times things look miraculous from a theistic perspective, but from a secular one, it just seems kind of like it has to be that way. So I'm going to dive into my arguments now. So that brings me to my first qualm with this argument, which is what I call selection bias masquerading as mystery, but it's more formally known as the anthropic explanation. I don't have a slideshow for this, so it's mostly text, but I'm sure Matt knows exactly what I'm referring to here. So the fine-tuning argument commits a fundamental error, in my opinion. It marvels that we ourselves are in a universe compatible with our existence, but I think that's kind of backwards. We couldn't possibly observe ourselves in any other kind of universe, right? I mean, this is not a coincidence requiring explanation. It's a logical necessity. Imagine a lottery where 1 billion tickets are sold to 1 billion people and you happen to win. Now, from your perspective, it may seem miraculous, right? You won 1 in 1 billion and you have a better chance of being struck by lightning multiple times than that happening. But in fact, someone had to win. And the truth is that whoever won would feel that same sense of improbability upon themselves. The winner's perspective creates the illusion of selection when in fact no further explanation is really needed beyond chance itself. And I'm saying that as a data scientist, a very advanced data scientist. I think probability is often overlooked. Well, not probability itself, but I think chance is often overlooked when it comes to very minuscule and infinitesimal things, such as the fine-tuning argument. So that is the anthropic principle in itself. Observers will always find themselves in conditions that permit observation, not because the universe was designed for them, but because non-viable universes produce no one to notice their absence. So in other words, we notice the complexity of the universe simply because we are here to. It couldn't be any other way. We are the lottery winners, marveling at our own luck, in other words. So even if we accept that our existence simply reflects observer bias, that we can find ourselves in a universe capable of supporting life, that the fine-tuning argument still faces a deeper problem. It makes me confident that probability claims without having the information required to support them that this probability claim without theistic scientists having the information to support them is what the fine-tuning argument rests on. It claims parameters are improbably precise, which is true, I would say, in appearances, when it comes to appearances. So I think only when it comes to appearances do I totally agree with that. When you look at things, when you look at the grandeur of the cosmos, things do look very delicately balanced. But that claim, to me, I believe, is meaningless, and to a lot of other scientists is meaningless because we simply don't have the data to make a claim like that. We don't know what the potential what the other potential outcomes were. We only know what we have. To calculate a probability, first you need a couple things. You need the range of possible values for each constant. You also need whether or not those values can change independently or are they tied together. So Matt in his presentation mentioned several times that if you change the value of one particle, that things will inevitably like become catastrophic, which is true. But that's only assuming that we leave other particle mass values the same. It's only assuming that we change the gravitational constant, but we leave all others the same. It's not adjusting for these constants not being intertied together. And so I think that's something that really should be considered when it comes to this argument. We can't just change one and leave the others the same. I think we have to allow each one to change. And I think that argument is, well, yeah, I think when you consider what's happening, I think it's a bit convenient that theistic scientists only want to change one and leave the others the same, or vice versa. You change the cosmological constant and leave everything else the same. And that's I think benefits their argument, because it is true. If you do leave one the same and you change, or if you do change one and you leave the others, then things break down very quickly. We know this to be a fact. So I think you have to consider the other possibilities as well, more so than just the one that maybe benefits your worldview. So we know these things. We've observed exactly only one universe, just one. So we don't know if these constants could have been different at all. We don't know how different they could have been, and we definitely don't know the likelihood of them being what they are right now, because we don't know the possible range of possibilities. And that problem runs deeper than it first appears. Most fine-tuning arguments take one constant, like I said earlier, and they'll change it. But like I said earlier, that approach is deeply flawed. In complex systems, variables rarely act alone. I'm sure that Matt could attest that they interact, they compensate, they balance one another. And so it's not necessarily fair to just change one and to leave the other ones unbothered. So yeah, I'm going to skip past that for the sake of time. Therefore, any probability claim is speculative at best and meaningless at worst, given the lack of data that we have in this scenario, in this arena. Physicist Sean Carroll put it clearly. He says there is no well-defined probability distribution over possible values of the constants of nature. And I agree with that 100%. We have to make a lot of assumptions in order to get to where we initially want to go, and the same goes for theistic scientists. The only thing that I think that the fine-tuning argument has going forward is the appearance of the well-balanced universe. So I think I'm just trying to skip past stuff that I think Matt already explained very clearly and that I agree with for the sake of time. I think maybe future research will show that these values are perhaps only mathematically consistent with what they are now, that they arise inevitably from a deeper, that they arise inevitably, not from a single deeper principle we haven't discovered yet. I think just as, well, I want to get there. Until we understand why the constants have the values they do, any probability argument is premature. I just want to leave that there. I think the greatest flaw in the fine-tuning argument isn't mathematical per se. I think it's historical, and I'm really curious to get Matt's opinion on this. I think it's historical and it's a tad bit psychological as well. I think throughout all of human history, when knowledge runs out for us, faith has always rushed in to fill the space. And for millennia, humans, we've credited divine action whenever we've encountered something that we can't explain or necessarily understand. Disease was punishment from God until germ theory emerged. For thousands of years, lightning was Zeus's wrath until we began to understand atmospheric electricity. The complexity of life more recently was proof of special creation for humans until Darwin revealed the mechanism of natural selection. Or another example I just thought of, for centuries, people believed that the universe revolved around the Earth. They thought that the Earth was the center of the universe. It's called geocentrism. It wasn't until Copernicus and Galileo proved that we're not in the center of everything. We're just one world among billions. And the Catholic Church actually really clung to that idea, not because the model itself was divine, but because it backed up what they believed Scripture was saying, that the Earth and that humans were special among everything in the cosmos. So again and again, God did it, has given way to natural explanation. There's been countless times where our species has attributed something to divine intervention simply based on a lack of understanding. I think ultimately, the fine-tuning argument follows the same pattern. It is considerably more complex than anything I just named, but as science grows, we expect the problems we face to become more and more complex, right? Yeah, we do. But I don't believe God did it as an explanation. It's actually the absence of one dressed in theology, more so than scientific rigor. And there's a physicist who I really like researching. His name is Victor Stinger, and he put it perfectly, I believe. He says science has advanced by replacing supernatural explanations with natural ones. We've done this for centuries, but it has never been done in reverse. So there's never been a time where we've expected something or predicted something scientifically, but religion came along and said, actually, this is how things are, and it was proved to be correct. It's always been science replacing religious claims, which I believe will continue to be the trend throughout all of human history. Every time we fill the gap in our knowledge, we found mechanisms and not miracles. And there's no reason to believe this pattern will sell in reverse. So I don't think the fine-tuning argument is any different. I do stand by saying it's the most convincing argument for creator, whether that be the Islamic God or the Christian God. It's very compelling. But it's not totally flawless. And I don't think this pattern of replacing theological claims with scientific proof will change when it comes to this argument. I think we are probably maybe a couple decades, maybe a couple centuries away from understanding now what seems to be divine intervention. So the fine-tuning argument endures not because it is empirically proven, but because it speaks to something deeply human about ourselves. We love pattern recognition. We love to feel important. And I feel like those instincts blind us sometimes to the same types of patterns that's taken past throughout our history. So when we examine closely the fine-tuning argument across several mediums, I think it breaks down. And I'm going to stop there.
Thank you for that, Sid. So next we're going to go into rebuttals. And yeah, Matt, feel free to use your 10 minutes as you like if you want to bring up some of the other points or respond to Sid's points. Go for it.
Yeah, I'll go for it. Well, I was going to say some stuff about the multiverse, but thankfully I don't think Sid has been trying to bring in the multiverse or contest much of the physics. So I think I'm just going to respond to some of the more philosophical claims that he made. So one was one thing that you mentioned was what about other unexplored possibilities, which I think is an interesting point. Like most of these searches that people have done look up quite a narrow range of parameter space. And so maybe there's an island of life possible somewhere far away. I think the problem with this is that that's just pure guesswork. We can hope that maybe that is the case, but it seems like we have no good reason to think that. In fact, we have good reason to think the opposite. That by looking around our life-permitting universe, that's the place where we would most likely expect to find life, and not in these far-off regions. So I think that's probably not a good argument. And then your other claim was that it's just selection bias masquerading as mystery. And I think that, it does seem like that. There is some sense of an anthropic principle that maybe we couldn't be there to ask the question otherwise. But I think that this is, faulty reasoning. So I'll give you the example of Leslie's firing squad. So this is, imagine there's a prisoner up against the wall with hundreds of trained marksmen, all with their guns loaded, aiming, and they shoot at him. And he stays alive. And he looks around and says, oh, well, I have no reason to be surprised. I have no reason to look for an alternative explanation. Of course, I must be alive. It must just happen to be that maybe the wind blew all of the bullets in the wrong direction. I mean, this is the level of improbability I think we're getting to in this argument. I think it's much more rational for the person who's been shot at to suspect that there was some sort of foul play. They should be surprised that they weren't killed, even though they couldn't have been there to tell otherwise. It seems very irrational to just be content to sit with the incredibly unlikely chance. And then you made the lottery analogy, which I think is fair. There's definitely something to that, if lots and lots of people buy a lottery ticket, then actually it's not that unlikely that someone will win. But the problem is we only have one universe, as you insisted. And so therefore, if only one person buys a lottery ticket, then that doesn't make it likely that someone will win the lottery. And the same thing here with our one universe. Then you made this claim about changing other values. What about changing multiple values at the same time? They do. In almost all the models, that is what people do. So in the graph, I showed the mass of the up and down quarks and the electron all changing simultaneously. So that's like all the fundamental particles. And then you can also try changing gravity, and there are other, like the cosmological constant, and there are other parameters you can vary along with this, like the density of, the fluctuations in the background of the universe, the curvature of space-time. And so people do these models. People try these models and see what happens, and it doesn't seem to, I mean, sometimes it changes the limit slightly, and people have found that, but this is something that people are actively investigating. It doesn't undermine the fine-tuning argument. And then you ask, could the constants have been different? And I think even if they couldn't, we still can't explain why they have the values that they do. You say we have no well-defined probability distributions over the constants of nature. But the problem with that is that we have to. Scientists, when we're trying to measure, say, the mass of the Higgs boson or the mass of the electron, we're doing the exact same thing. We have to have some background probability using Bayesian statistics, which is where we have our background probability. What's the likelihood of a value taking, say, the electron has a particular mass, and we look at a particular range. Usually it's based on the Planck mass for dimensionful quantities, say quantities with a mass. And so we look at this range and we have a uniform distribution, and then we say, given the experimental evidence that we observed about the mass of the electron, how does that change the probability of what we expect the electron mass to be? And so you can say that we shouldn't be doing this, but this is what scientists are doing. And so you might be attacking a lot more science than you think you are when you say something like that. And I think that a Bayesian approach is the best way to analyze this. And then finally, you mentioned something about God of the Gaps, which I thought was interesting, and about the relationship between religion and Christianity, which is very much not necessarily the topic of the debate, and I'm not prepared to talk about that, but I'm very happy to talk a bit about it. So I think here, that doesn't apply. So the reason why I don't think it applies is that we're looking for the best explanation. If it turns out that there is a scientific explanation, great. But then we can just ask the same question again. As I mentioned, the big question at the start of are the laws of the physical universe what we would expect? We can just ask that question again on these new set of physical laws. And maybe there will be fine-tuning, maybe there won't be. We don't know. But more than that, we're looking for an explanation underlying the natural laws. So rather than trying to squeeze out the natural laws, we know that they must have a limit. Science is basically just explaining the physical phenomena in terms of scientific laws. But science can't answer why science works, or something like that, the things that come before science, and why the constants have the values that they do. Science can't explain these types of things. And so we need something else. And you mentioned that it was a historical pattern. At least in the case of fine-tuning, this definitely isn't the case. So it's been going around since the 70s or 80s, and people have been looking at looking at deeper and deeper levels, and they've been finding the same sorts of fine-tuning. It hasn't seemed like fine-tuning has become a smaller problem since then. In fact, based on these calculations, it seems like a pretty big problem. And so I don't think that this is a case of science and religion trying to fight out for the best explanation, but it seems like science has raised a question that it can't answer in and of itself. It can't answer, is the universe the way that we would expect, because all science is doing is describing the universe with all its constants and laws. But then when we want to say, why is it like this? And we have to turn to our worldview, which on naturalism, it seems like using methodological naturalism, scientists make estimations for what they would expect constants to be over some probability distribution all the time. But then when we apply this to the fine-tuning problem, we find that it gets us very surprising results. And I don't think that's just a psychological effect. I think that when we're making these probability calculations, they are accurate and are telling us something. Yes. Do I have more time, or am I?
You do. You have 3 more minutes, but you can stop
minutes. Okay, wow, that is more time than I thought. Maybe I've been speaking too quickly. I'll say one more thing then on your point about religion and Christianity, and this idea of historically Christianity and science have kind of been in conflict, and wherever there's a gap, Christianity try and shove themselves in and use God to explain it. And I really don't think that's the case. I think that when you look at the origins of modern science with people like Galileo and Kepler, astronomers, their perspective was that the reason why they were analyzing the natural world was because they were Christians. Kepler, for example, said that he was thinking God's thoughts after him. And so what he was doing was he saw the natural world, he saw what the Bible said about the universe being created to show God's glory. And he wanted to try and mesh those things together and to try and see something about God's goodness from creation. And that wasn't because he thought that God was for some reason pushing Earth as it was going around the sun, but because he thought that he was the one who'd come up with the original mathematical plans and designs behind this. And I think that's why this valuing of creation, this valuing of God's design order is why science did arise in the Christian West, rather than, say, among the ancient Greeks, where they were very good at maths. But when it came to analyzing the real world, they weren't so keen on doing that because they didn't have the same level of value of creation as Christians did. And I'll leave my time there.
Thank you so much, Matt. Lots more things to bring up and talk about. Go for it, Sid.
Yeah, absolutely. I'm going to try to make mine quick because I'm very anxious to get to the discussion portion, just as you said earlier, James. Yeah, so I anticipated, based on your background, that you would handle vast majority of the technicals. I can't explain what you explained better than you, so I figured I would tune in to the philosophical side so we could talk about that as well. And I knew that you would handle the technicals as well as you did. I've never worked in a physics lab before, so I'm not going to pretend to know more or pretend that I could convey what you conveyed better than you did. So I think there will be a nice balance here for the discussion. But just moving in, I'll answer your questions or your rebuttals in retrospect. So from what I researched, as I said, I've never worked in a physics lab, but from my research, and I'm fairly well read on physics, but have no hands-on experience in the field. I think I did not convey my position as well as I should have. So for what I'm read, it seems that when these arguments are considered, values are only changed incrementally. But from what I've seen, if you change them, like it's never the case that we're simulating changing them a lot. Like we've never dialed the gravitational constant up to like 11. It's always changing them in very small increments and seeing what happens. And so I didn't convey that well, but that's practically my position, is that we don't know what could have come from we don't know what could have come from changing the constants like very significantly. We just assume that they always have to be within this very small range. And from what I've researched, that's not necessarily the case. And then I'll tackle the godly gaps really quick. I think it's not necessarily Christianity versus science. I do 100% acknowledge that a lot of the most important scientists in the history of mankind have been, Christ followers. Isaac Newton is my favorite scientist of all time, and he was a notorious religious man. So it's not necessarily science versus Christianity. I've always seen it as kind of science versus ignorance. And I don't say ignorance as an insult. I say it as just the general state of things, 3,000 years ago, we didn't know anything. And from my point of view and many others, it would be that because we didn't know anything, we used scripture or religion. And notice I mentioned Zeus as well because Greek mythology predates Christianity, and before Christ and the God of the Bible was there, people were attributing weather phenomenons to the Greek pantheon. So it's more so us as a species attributing what we don't understand yet to divine intervention. And I think you would probably agree with that. That's been a pattern. So the fine tuning hasn't been around for that long, like you said, just the last 60 years or so. But the pattern I was speaking to is the God of the gaps in general. So as something comes along that we can't necessarily convey what our like current means, and we automatically rush to use faith to fill in that gap. I don't think that's a productive thing for our species, given how it's never really served us well in the past. So if you want to discuss that more during the discussion, we can. And then when it comes to particle masses, once again, I've never worked in the physics lab. Everything I know about it, I've read, and I've read quite a bit. But I was doing some research on the LHC in CERN, Switzerland, and from what I saw was that like the Higgs boson was something that physicists were using like to kind of disprove the fine-tuning argument more so than to prove it. They saw it as like a puzzle to solve naturally, not supernaturally. So I would love to like learn more about that if you think that the Higgs boson is being used, or if you think that the state of the Higgs boson and that its existence is more evidence for the fine-tuning than not. I'd love to discuss that as well during our discussion phase, which I'm very much looking forward to. I plan on asking questions and like disagreeing with you during the discussion phase, and so I would just like to maybe just dive into that, James, if you're okay with it. I think that should give us a lot more time than me just sitting here talking, right? Because we're here to like talk to each other.
Yeah, I mean, I'm happy for you to ask me questions during your and talk over me if you want to as the remainder of your rebuttal time.
Yeah, go ahead, Sid. You guys can jump into it. Since you could bring the first question.
Yeah, absolutely. So from what I've read, the work being done at the Large Hadron Collider has not necessarily been in support of an intelligent designer. Now, of course, these are secular scientists doing this research, but I'd like to think that I'd like to give most scientists the benefit of the doubt and say that they're not, allowing their atheistic nature or theistic nature to change to affect their how they're conveying their research. From what I've read about, I would like you to like explain more about your opinion regarding like the Higgs boson particle and just particle masses in general, and how you believe they point to an intelligent designer when so many people in your field would disagree with you.
So I mean, I haven't heard so much about the Higgs boson being used to try and undermine intelligent or design or fine tuning. I mean, there is the fact of it providing mass to the fundamental particles, which we couldn't explain before. But to me, it seems like what the argument is essentially is when we look at these fundamental constants, we find that the universe is balanced on a knife edge, that it's in a very precarious position. And if we move any of these constants a very small amount, then things go very wrong. And this is true with the up and down quark masses, true with the electron mass, and also true with the mass of the Higgs particle, the Higgs boson. So the Higgs, I don't know if you know much about fields, but so we have like the electromagnetic field, which the electron and protons interact with because they're charged. And then we also have the Higgs field that the fundamental particles interact with, and that gives them mass. But like the electromagnetic field can be excited to have photons, the Higgs field can be excited to create Higgs bosons. And the problem is that when a Higgs particle is in the Higgs field, it's actually interacting with itself. And this is true of electrons too, interacting with the electromagnetic field. But when you add up all the contributions of the electron with itself, even though you have to add to an infinite number of terms, they converge. They eventually get so small that they don't make a difference, and you can still get out a nice number at the end. But one of the problems, other than, at least to me, this doesn't seem like quite a fine-tuning problem, but with the Higgs boson, when you try and do that, it doesn't converge, it doesn't go to zero, but it goes to infinity. And so then if we bring in the limits of our theory, the Planck mass, the reason that's our limit is because at that kind of mass, a particle would spontaneously turn into a black hole. And at that point, we clearly need quantum gravity, and our theory is not quite working right. And so if we cut it off there, then the value we get of the Higgs boson is around 10 to the 16 times more than what we actually observe. And so it seems like there must be some kind of cancellation there. We're expecting some reason why it will all cancel out, but we don't know what it is. And we don't know why it's so precise. It seems like there's some mechanism that someone has brought in to cut it all exactly off. And that's aside from the fact that even if the Higgs mass were varied by, say, 100 times, because it's the interaction with the field is what gives mass to the other particles would become so massive that you get big problems. But there we go. Sorry, I've spoken for a long time.
No, man, you don't need to. These are very complex things. You can't explain them in 20 seconds. So I completely understand. Take as much time as you need. What would you say, and I'm not even sure you can answer this, but I'm really interested to get your opinion on it. You think that underlying probability distributions for particle masses is something that we can determine. From what I've read, that's not necessarily true. What would you say the underlying the underlying probability distribution is for the Higgs boson? And have we measured it?
Yeah, so that's a good question. And I mean, I realize I should have said this. I am an experimental physicist, but not in either particle physics or cosmology.
Okay.
So this isn't my expertise either, but I have studied particle physics. So the thing with the underlying distribution is that ideally this underlying distribution has a very small effect on the actual estimate that we get at the end. So this is just the Higgs mass must be some value that our theory can handle. So it can't be the Planck mass, because if it was the Planck mass, then we'd be reaching the ends of our theories. We'd be having quantum gravity, which we can't explain. It also can't be zero. It can't go negative, so it has to be greater than zero. And these are the two limits. We don't know where it is. And say in this case, we can probably assume a relatively uniform distribution. So each of the values across there has a similar probability. And then with that prior probability, then we can take in our evidence, take in our data, and work out what is the probability of getting this data given our hypothesis is true. And then by using, this is Bayes' theorem, which I imagine you'll understand as a computer scientist, but maybe if anyone listening doesn't understand, maybe you'd be best placed to explain this. But essentially, the idea is that we have our prior probability governing the probability that of the Higgs boson having any particular mass in this massive range. And we say that they're all equally likely. And then we say, given the data we've observed, how does that update our probability of the different masses of the Higgs boson? And if we have enough data and it's precise enough and a precise enough theory, then actually it doesn't really matter very much what probability we choose, even if it wasn't uniform, because almost all the final probability depends on is the distribution in the background. Is the evidence, the data that we observe. And I think we can have a similar thing with fine-tuning, where because the constants are so finely balanced, in some ways it doesn't matter very much what particular distribution we choose. We're always going to have the fine-tuning problem because the life-permitting range is so small. We can choose a uniform distribution, and we could maybe choose some other distribution, but we still end up with a similar, you get different numbers, but you have a similar problem.
James, how much time do we have?
We have lots of time. 20 minutes. So I have some questions if at any point you'd like injection of new discussion things. But
No,
yeah,
no,
go.
absolutely. I have, so I would like, I thought that we were using our rebuttal time to ask questions. I wasn't aware that we had moved into the discussion portion, which is fine.
Mm.
Because I want to give Matt a chance to lead discussion as well, but I'll ask one more question. So I saw you had slides for the multiverse, but ended up removing them. So I've done as much research as someone who, is not an expert in the field could do. I've read hours up on it. It seems to me that because the multiverse theory is grounded in actual experimental physics, theoretical physics, string theory, I believe, eternal inflation, that it's far more parsimonious of an explanation than invoking the supernatural. And so when you use terms like Bayes' theorem and you're going into Bayesian reasoning, would you also apply that to the multiverse theory? And if so, would you think that that makes it more likely than the supernatural explanation, which we can't test because we have no prior historical data to base it on?
Yes, that's an interesting question. So I was quite glad when you didn't bring the multiverse up, because to me it seems very much like someone who's essentially seen the weight of the fine-tuning argument, and is just trying to run away to
Yes.
the multiverse of the gaps,
Yeah.
if you like, where no one actually believes in a multiverse if you go around and ask them. But because it seems to explain this quite well, people retreat to that, which I think is actually more than a problem for the parsimoniousness of the multiverse as opposed to, say, theism. Whereas with theism, I wasn't I didn't learn about these constants and then propose a God to explain them. But people have believed in a God for many, many different reasons for thousands and thousands of years. And this is just another thing another theory that it naturally explains. And I agree that it's not a scientifically testable theory, but at the same time, this argument is a probabilistic argument. If we found that actually there was a wide range of life permitting universes, then this argument would fail, and then we wouldn't have evidence in favor of God's existence. So even though it's not a scientific theory, I think that just believing in a multiverse as an explanation for fine tuning also doesn't seem like a very scientific theory to me. No one has like a rigorously well-defined, well-grounded scientific model of the multiverse. They all seem to be based on very speculative physics. And I think if we're getting to the stage of proposing infinite other universes to try and explain this problem, then I think the fine-tuning argument has already done a pretty effective job.
Yeah, I think I do agree with you. I didn't put it in my opening statement because I do think that any person that goes into a debate like this and tries to invoke the multiverse theory is just grasping for straws. I think it's highly unlikely. It's kind of silly. I don't think it can be dismissed in totality though. If you're comparing the other alternative to, like, if the other alternative is a supernatural deity, I don't think then you can wholly I guess dismiss the multiverse theory because they are both um pretty far out there given the amount of evidence we have for them. And the reason I say that, I think the multiverse theory will hold up under Bayes' theorem more so than your supernatural explanation, is because although it is grasping for straws and highly unlikely, it is still grounded in pretty important and like stable physics that's being studied by some of the smartest people on a planet. So it's not like we don't have like a half of a foundation for it, at least, as to where for the theistic argument, all you have is, well, this seems pretty unlikely, so there must be God. Like there is no foundation there outside of the improbability of things existing the way that they are.
Yeah, I mean, it's more than pretty unlikely. It's slightly astounding. But yes, I see your point. So I mean, to go through my rebuttals to the multiverse, my I think three main points are, so one problem would be if we have a multiverse, we have no reason to think that this will solve our fine-tuning problem. It seems just as plausible that whatever mechanism we have for generating universes may need to be finely tuned. In fact, it seems like given the multiverse has to create universes that are not zero entropy, but are also, sorry, not incredibly high entropy, but also are able to create some sorts of life. It seems like there's going to need to be some fine tuning there anyway. And then a second problem would be the problem of Boltzmann brains, or essentially if you have some mechanism for generating lots and lots of universes, then given the incredible unlikeliness of a universe like ours, it's much more likely that you're going to get a universe where there's some small amount of order, say a brain appearing for a moment, a collection of atoms that can have some experience that appear for a moment and then disappear, which is not at all what we see. We see a universe that's ordered throughout. We see stars and planets and galaxies as far as the eye can see, which is not at all what we would expect on the multiverse. And then finally, there's the issue of simplicity. Like I think I kind of mentioned this earlier, but any scientific theory, any theory at all, you can always solve if you just posit more things. If you have more objects in your theory, then you can get any kind of observations you want. But that's a problem. And I think that's part of the strength of Occam's razor, that when we look for simpler explanations, we tend to be going more along the right lines. And this is another problem with the multiverse, where we just end up positing more and more and more universes. And maybe this solves our problem, but at the same time, that's quite a high ontological cost. Do you mind if I ask a question, or did you want to follow?
I was going to say, it's all you, man.
So I made the analogy of the firing squad with lots of people shooting at man, and he wakes up and is, or well, not wakes up, but he opens his eyes, finds that he's still alive. Do you think that he should be surprised there? Or do you think he shouldn't be surprised and it's completely irrational for him to expect to be alive?
No, he should be surprised.
Okay. Sounds good.
So then, yeah, I agree. I agree with your analogy.
Yeah. So then, do you think that applies to the fine-tuning argument, where we wake up and find ourselves in an incredibly improbable situation? Do you think we also should be surprised that we find ourselves in this situation, even though we wouldn't have been able to know otherwise?
Yes, I think that's a really interesting question. And after this debate, if I had known you were going to use that analogy, I would have brought some clips with me, or some links. But there have been multiple times throughout history where firing squads have shot at a person and they've all missed. And so we have empirical data for this actually happening. And so no matter how, no, that's not true. Your example was like 100 people on the firing squad, which most likely they would not all miss. But there's multiple times I've read articles about 10 to 15 people on a firing squad shooting at someone and them all missing. So like I don't think that idea is like totally unlikely or like not bound to happen, given that we have actual mundane Tellurian like experience of it occurring. And then as far as the young man or whoever being surprised that he's alive, yeah, I think any person would be surprised that he's alive. But me myself, putting myself in his shoes, being as unbiased as possible, I don't think my first thought would be like, oh, God saved me. It would probably be some sort of naturalistic explanation. Maybe the wind did shift. Wind can affect bullets very much, and we know this to be true. Maybe I was shot and I survived, and I just realized that I think there's a lot of naturalistic explanations that would occur to me before I would try to invoke the supernatural. Now, if they all fired at me and every gun instantaneously jammed, I think that's maybe a better question. But
why?
Well, because one gun jamming is improbable. Two gun jamming, two guns doing it is, it increases by an order of magnitude. However, if you have every single gun jam when all firing at the same time, I think that maybe not even supernatural, but that would cause question for like, okay, maybe there's like some sort of outside tampering outside of me and the 15 people trying to shoot at me, whether it be their commander tampered with their firing pins, or maybe even a god snapped his fingers and they all jammed. But because I don't know of any things like that happening all at the same time, I think that would be more of a better analogy, if that makes
Yeah,
sense.
that makes sense. But I think that like the probabilities involved in this argument are much, much more unlikely than 100 guns jamming it at once. Like 10 to the power of 100, 123 is like, this is more atoms than there are in the universe by like a long, long way. And so I think that, yeah. And
Yeah.
aside from that, we also have like, I agree that maybe it would make more sense to look for a naturalistic explanation in the cases of the guns jamming, like they've been tampered with. But in this case, we're literally out of naturalistic explanations. Quite literally, we've reached the edge, and then we're looking what's there, and we find something incredibly improbable.
So
Which, yeah, sorry, go on.
just no, just to be so you're asserting that we have, like, as scientists, we have reached our frontier when it comes to physics, and that we can't go beyond where we are now in answering this question.
Um, so potentially we can. Like I think that it seems very plausible that maybe we'll come up with a theory of quantum gravity. But the problem is that that's just as likely to have more fine-tuning problems in it as it is to have less. And so I think that trying to use that as given that we'll never be able to, well, at least to me, it doesn't seem like it'll take a very long time. It's probably not going to be in our lifetimes that we manage to reach the end of our scientific process, and say this is our final explanation. We should work with what we have at the moment.
Yeah, absolutely. Matt, I may not make a very good debate buddy because I don't disagree with you there. I do agree that the universe does appear to be fine-tuned. I think I may have mentioned, I know I skipped a lot of my opening statement for time, but I definitely agree that it does appear to be fine-tuned. However, looking at a world through a naturalistic lens, think that it's much more likely that we will, although we can't figure it out now, we don't have answers now, that we will have answers in the future. And my my understanding of this, and I guess my driving force for believing this, is the historical pattern that we've shown as humans to be able to overcome all types of odds when it comes to scientific questions. I mean, we in the mid 1800s, the atomic bomb would have seemed like magic, but because of atomic theory, less than 100 years later, we had technology that would have confounded even the smartest physicist in the early 1800s. And so I don't think it's necessarily, no one was even thinking about, like what quantum mechanics would bring forth in terms of like our capabilities and our understanding of the universe. And I say understanding like very nuanced there, because I don't think anyone really understands quantum mechanics, but
Don't be rude about quantum mechanics. No, I'm joking.
I try, man. That's math I can't understand. But I would agree with you that it would be highly unlikely, and that it would appear that outside forces were tampering. I can't, like any intellectually honest person would have to, concede that. However, I just think that in the terms of like on a grander scale, when it comes to the universe, um, because there is no grounds for, like, we don't have a grounds outside of like looking through a theological lens for anything supernatural, but there is no like physical, tangible, scientific ground to like found things on. I would always say that a naturalistic explanation is more likely because of the work being done in those fields, no matter how grasping for scrawls it may seem like the multiverse. So that would always be my position. But you're right. I think things are pretty wonky. Like it looks, yeah.
Yeah. Yeah, I think I see your point. Yeah, and I won't agree that in the past lots of people have made lots of bad, or arguments that I would disagree with, at least whether they're bad or not is a different matter. But lots of people have made arguments that I don't think work for God's existence. But I don't think that you should let that put you off trying to work out what the truth is. I think that it's still worth you considering that. And I think that you say we have no reasons other than theological to believe in the existence of God. But I think this argument is a good example of a non-theological. Well, I guess I put some theology in when I quoted the Bible, but there's not much theology going on here. It's almost entirely looking around at the universe, trying to explain it, and it seems like a God is the best explanation. And given, if we use Bayesian reasoning to compare the naturalistic hypothesis and the theistic hypothesis, then given the scale of the probabilities involved, are you really that certain that God doesn't exist? That like is your, I mean, this is slightly playing loose with the terms, but is your certainty more than 1 in 10 to the 130 that God doesn't exist? Because if you're that certain, I would be interested to hear some of your reasons. But that is, I don't know, that's a very strong sense of certainty that you have.
Yeah, yeah, it's not certainty at all. Well, one, I'm not I'm not certain about anything. I have differing degrees of, surety about different things, but I'm not absolutely certain about anything. I think James may have PTSD when it comes to Bayes' theorem. Um, but
Indeed, yeah.
I think when invoking that, just from a purely like statistical mindset, like you can't, but because you're saying you're not invoking theology, then you have to be completely like unbiased when using Bayes' theorem. And because as humans we have no like certifiable, tangible um instances of supernatural things happening, like we even miracle claims are like heavily disputed. You would your prior probability would have to be set to near zero, because we have no evidence of anything happening in that way. And I'm not saying that the multiverse theory, or any other naturalistic explanation will be close to one, because it's not. But the prior would be higher because that those alternative theories are grounded in actual, scientific methods that are like answering questions that are pretty important. So like I mentioned earlier, string theory, kind of wonky. I don't completely understand it, but I know that it plays into the multiverse theory, and the same with eternal inflation. So I would wonder, like, would you agree with that because we have no history of being able to confirm supernatural occurrences, that would then there, like using Bayes' theorem at least, make it less likely to have happened, like to be the cause of the universe existing than a naturalistic one that is just as probably nearly unlikely, but still slightly more likely given the experience we have in implementing some of the methods.
Yeah, that's really interesting. I mean, because I do agree that one way that you could kind of get around this argument is if you just set the probability of God's existence to zero, like to literally zero, then you're never going to be convinced. And that is quite like I'm not quite sure how to respond to that. I guess my first thought as a response would be, if you're going to set the prior probability of God's existence to zero, you must have some pretty strong evidence for that. And I think that just saying we haven't observed it doesn't seem like very good evidence at all. So say, I mean, this is again science, but it's another theory. Say with Einstein's theory of relativity, if someone had come along in the 1600s and explained that to someone, they wouldn't have any evidence for it. It was looking at the orbit of Mercury that made people realize that there was something. Well, that was one of the first confirmations of Einstein's theory of relativity. But if you explain that to someone in the past, maybe they wouldn't have any evidence for it. But if then they assigned it a prior probability of zero, or close to zero, then when all the evidence came along, they would be very hard to convince. And so I think that when you say, oh, we just haven't, I mean, one thing is you could contest whether we have observed supernatural things, but when you just say, "Oh, I haven't observed supernatural things, so I'm going to set the prior probability to zero," I think you're playing a very dangerous game. And I think that if you
Oh, sorry,
did
I
that,
meant to
sorry,
say, if I said zero, then I misspoke. It would be
yeah,
near, which I mean, it would be non-zero, but still pretty close, which is probably still the same as it still probably serves your purpose, what you're saying. But I'm not absolutely certain that God does not exist. And I wouldn't set it to zero, but yeah, I just wanted to ensure that you weren't thinking that I said it was like completely zero.
yeah. I guess I'm sorry, that was me being unfair. I guess the reason why I said that was because if we're talking about 10 to the minus 130, then we're so close to zero that like I think it's yeah. Anyway, my point was that I think that you need some very strong evidence if you're going to reduce the prior probability that much. And it seems like your claim, I haven't observed it, is not strong evidence. And that if you had a similar way of interacting with other beliefs that you haven't observed, yet. Like take for example, I don't know, someone who has never seen, someone who lives by the equator and has never seen ice form, and so then they've never seen and never observed it, and so they set the prior probability incredibly low, which I think. I mean, I'm struggling to think why that wouldn't be justified. But the problem is that like ice does freeze, and if someone explained to them that ice does freeze, and they didn't change their mind, then we've got something going wrong. Maybe they're being rational, but it seems like there's something going wrong. And I'm worried that you're in the same position here, that you've set your prior probability so low that we could have something like God writes in the sky, the verses of John 1, and you're like, well, the prior probability is so low that I'm not going to change my mind. Do you see my worry?
Yeah, absolutely. And believe it or not, if God wrote John 3:16 in the sky above me and I didn't see like any planes around that was there to do that, that would be very compelling. Um,
Why?
I don't want my
Why
friends
would you be
watching this.
compelled?
What'd you say?
Why would you be compelled?
Well, I mean, if there was no, like, if I was outside one night and I was asking God for a sign, and all of a sudden in front of me, John 3:16 appeared in the sky, that would be very compelling. There would be very few naturalistic explanations that would be able to explain that. I would be compelled to probably start to believe something. If not
I think the
Christianity.
reason why you'd be compelled, sorry to interrupt, I think the reason why you'd be compelled would be because it would be so unlikely on naturalistic explanations.
Yes.
But I think it would be more likely than the probabilities we're dealing with here. But sorry, go on.
Yeah, well, I wanted to say I don't think your like view of my probability set is totally fair. Okay. Imagine this. Imagine you have claims for a certain kind of phenomenon throughout the entire of human history, and none of them have been able to be confirmed by mainstream science. We've confirmed no miracle accounts. We've confirmed no supernatural instances, no, divine weather instances or something like that. Like everything that we have that's been claimed to be miraculous has been explained by some sort of scientific mechanism. And so we have all of these things in the past being complained, I mean, being put forth, being asserted, that's been proved away by modern science, or sometimes even ancient science. I mean, Eratosthenes was able to prove the Earth was round using a stick and a shadow, which is pretty cool.
Very
And
cool.
so what I'm saying is it's near zero for me because you have all of these claims throughout human history from differing cultures, from differing religions, from on different continents, and none of them have been able to be confirmed. Like no type of supernatural instance has ever been able to be confirmed. And you could argue that we've only had a couple centuries of like really like being able to record things of that nature, like and be able to test them. But still, even then, like I've not seen any miracles as claimed in the Bible occur, and no one else has either. And if they have, it's not been recorded or it's not been like confirmed by mainstream science, which I think is you have to admit is a bit strange, right? And so I think and you can confirm that ice exists. Like even if you are in South Africa and you've never seen snow before, it's pretty easy to confirm that ice exists. You can go on the internet or you can get on a plane. I can't just get on a plane and fly to the Vatican and like see an exorcism happen and like know that it's actually real as to where Antarctica is actually, I think, one of the closest continents to Africa. So it would be pretty easy for someone near the equator to confirm ice exists. So in my mind, I set the probability of the supernatural being the reason for the origin of the universe to near zero because we have no confirmed instances of it actually existing or occurring in the past. If we did, then of course that would change. Now, you could argue that, like perhaps, like I don't want to see, or that like I'm being blind to miracles happening in front of me every single day. But that would be a theological argument, I would argue, because it should be easy to confirm miracles, as easy as they were to confirm in the Bible. God was not stingy with performing miracles in the Old Testament, and so I think that if they were actually happening today, it would be fairly easy to confirm, which would heighten the prior probability of supernatural occurrences in our world.
Yeah. Okay. I think I don't know. I think I found a problem with what you're saying. You can tell me if it's actually a problem or if I've just got confused. But to me, it seems like one thing that you have to account for, again, going back to your Bayesian theory, is the probability of the evidence given the theory. So that's in evaluating the probability of say, observing miracles, I think it's not enough just to say, oh, God exists, so therefore I should be expecting to see miracles, or I don't see miracles, so therefore God doesn't exist. But I think you have to analyze what is the probability that Cedric Paige would see miracles given the Christian God exists. And in my understanding, I think that may well be very low. And so I think that both naturalism and Christianity predict that you wouldn't see many miracles. I think that the reason there were lots of miracles around the time of Jesus was because it was a very special period in salvation history. In fact, in the Old Testament, there aren't many periods where there are lots of miracles, but there are some, particularly when there's prophets coming, and when the Israelites are rescued from the Exodus, which is another very specific moment in salvation history. And so, whereas nowadays, I don't know. I mean, I think it's a nice time to be living. I enjoy it, but I don't think it's a particularly special time in salvation history. And so I think that Christianity predicts that we wouldn't expect to see many miracles. But what Christianity does predict is that God would create humans, would create life for him to love and have a relationship with. And so then on this prediction that we don't expect, we don't see it. And you're counting that as very strong evidence against. But I don't think we even expect it. Whereas this thing that we do strongly expect of life is very unexpected on naturalism, but is very strongly expected on Christianity, which I think is why the fine-tuning argument is so compelling.
Okay, let me ask you something. Do you believe? I think, because almost every single person I love in my life is a Christian, and they all speak of miracles happening around them all the time. And so my question is, in a world where nothing can go for more than a couple seconds without being recorded or confirmed, how is it possible that these occurrences are being claimed, but none of them are being confirmed? So I don't expect to see miracles because I'm not a believer. And I think because miracles are being so heavily asserted for the reasoning behind certain phenomenon, that I, as someone implementing Bayes' theorem, like it's not, I'm not wrong in saying, well, these are being claimed, but nothing's being confirmed. Therefore, we can't hide your prior because of this. Like, we need more evidence in order to make this more of a serious possibility. So it's not that I'm looking for miracles, it's that the ones that are being claimed are not evidenced enough to be confirmed by mainstream science. Whether it be a patient being cured from cancer, it happens all the time, but a religious family would call it, a miracle of God. And so that's not evidence for a supernatural creator, if that makes sense. And that happens all too often, I believe. So I think that's where my assignment of a near zero would come from. The same reason I'm going to stop there because I don't know how much time we have, and you may want to ask another question. But yeah, that's pretty much the totality of why I believe it's near zero, is because of the lack of evidence in a world where everything is recorded in digital.
Yes, I think I see your problem. So I think there are two compounding effects here. So I think one is, in my opinion, I don't think necessarily supernatural miracles are all that common today. I definitely think God is able to do them, but I think that lots of the way that God works in the world today is through the natural laws that he upholds and sustains. It seems like God loves making natural laws. That's why science is so amazing. That's why I love being able to study atoms and shoot lasers at them and see what happens, because that's the way God designed them to be used and the way he decides to uphold them. And so when a person is cured of cancer, I do think that's an amazing gift of God. I don't think often a supernatural event has occurred there, but I think that God has worked because he is able to work through the laws of nature and through the wisdom of doctors. And so I think that's the first effect, that lots of the things that God is doing, he's not doing supernaturally. And I think the second effect is that if I already believe that God is active in the world, then it might take a lot less evidence to convince me of a miracle than it does to convince you of a miracle. And I don't think that that's a problem on you. I think that you're justified in saying, this thing that happened, I'm trying to think of a silly example. Maybe I remember for my birthday last year, I was trying to book a pub to go out with my friends, and it was not working very well. I prayed about it and it worked out, and that was great. And I think that in some ways that was God working. I don't know whether it's supernaturally or not. And I don't think you will be convinced by that. it would be irrational for you to be convinced by that. But at the same time, it would also be irrational for you to say that's definitely not a miracle, because we don't know whether God was working supernaturally there or not. And so I think that you're justified in saying, even I sometimes, when Christians will make miracle claims, I'll be like, actually, hold on a second, I'm not convinced by that. But I don't think that you should then let that feed into your belief that God doesn't exist. The fact that these miracles you don't believe. I think that instead you should, reason on things that we do have evidence for, on arguments and reading the Bible and stuff like that.
Gotcha. James,
how much time do we have?
Thank you so much. We'll probably bring the discussion section to an end. We have a few Q&A. Maybe I can remind anyone who's listening, if you click just down below in the description below this video, there is a link to a place where you can type in your questions. And if you type in short questions, they'll be more likely to be answered. And you can upvote questions that you would like to answer. So get typing. I'm sure there's lots of thoughts and questions that have come up from this. I'm going to have a few questions to ask as well. I'm looking forward to this time. We did have a time of sort of concluding thoughts from maybe Matt and Ced. Maybe you can sort of summarize how you think the arguments have come and what you think our conclusions should be from this. And then we'll get into a time of Q&A. So Matt, maybe you could have your 5 minutes concluding thoughts.
I have just remembered about this, and so I haven't really prepared anything. I'm just going to wing it. I think, we've seen that there are good, that when we look at the science, when we look at the values of the fundamental constants, and we try varying them, we're very surprised that rather than what we would expect on naturalism, that we live in a wide plateau filled with lots of different areas where life is possible. We live balanced on like a pencil balancing on its tip. And this is really surprising. And I think the level of the surprisingness is so significant that we need an answer. We can't just be like the man in the firing squad who isn't surprised that all of the guns jammed. We have to be surprised at what happened and look for an explanation. We have to ask why, as is the scientific method. And I think we see that when we do this, there aren't many good explanations for what happened. I think that the multiverse has many flaws, especially if you're just introducing it to try and explain away the fine-tuning problem. Whereas I think that the Christian belief that God is a loving God who desires to be in a relationship with people and therefore would choose to create a universe not only that supports life in one small area, but the whole heavens display God's glory. We see stars as far as we can see. 13.8 billion light years away, we see stars, and it's beautiful. And I think we see God's love even more in sending His Son to earth to relate to people, and in His death on the cross, through which we're able to have relationship with Him. I think on Christianity, the God who loves to relate to people, fine-tuning makes perfect sense.
Thanks, Matt. Ced, maybe your summary and concluding thoughts.
Yeah, absolutely. So I think I wanted to take this opportunity to mention something that I didn't necessarily think of earlier. Well, I think I did. It didn't flow naturally into the conversation, so I didn't bring it up. I think for me, when it comes to, like, as an engineer, thinking of how I write code, how I build systems, I think I would actually perhaps argue that because the universe is balanced on such a knife edge, that's an argument against design as well. I don't want to go like too deep into it, but I'd love to talk to you about it, Matt, offline if you like have thoughts on it. But when I'm building systems, very complex systems, they can fail pretty easily given all the different functions and methods that are intertwining together. However, if you build a system where like one thing failing or changing or going off according to plan crashes the system, that's very bad engineering. I'm constantly building in confidence bugs and error corrections and flowcharts and things like that to ensure that no matter what happens, no matter the no matter what happens in my programming, it's always going to flow naturally. It's not as fragile as the universe would seem to be. And if I was an all-powerful creator and I was creating something that my precious creations would be subsisting in, I don't think I would make it as fragile as our universe seems to be, or that Matt has very clearly just demonstrated that it is. That's something to think about as well. I also think that in regards to Matt's comments about particle masses and the constants, about us understanding the underlying probability distributions, I would challenge that a bit. I didn't challenge them as much as I probably should have, simply because I'm not an expert and I have a better understanding than the layman, because I read a bunch, but I'm not a physicist. I would challenge the thought that we understand completely the underlying probability distributions of these constants and these particle masses. I think they are much more unknown than Matt may have portrayed them to be, and that because of this, we can't definitively say that what we have where we are right now is more unlikely or less likely, more likely or less likely than another parameter set for the universe. We don't know what those ranges are. We don't know what things could have been, and we don't know if one. Well, hopefully, we will know one day. I think an amalgamation. Matt made really good points. A lot to think about, a lot to consider, especially that last bit of the conversation that we were having regarding miracles and like applying Bayes' theorem. But I'm still not wholly convinced that although the universe appears to be fine-tuned, that it actually is.
Thank you so much, both of you. So just a reminder, listeners, if you click on the Vvox link below this, you will be able to submit your questions. If you have my WhatsApp number, you're welcome to send questions on WhatsApp as well. And we will hopefully get that answered. So, Ced, thank you for bringing up another point there. I actually was going to ask a very similar question as my very first question for Matt, which is, if we have this universe balanced on a knife edge, people like Alex O'Connor have brought up this question of why would God design it so it's balanced on a knife edge? And doesn't that make it? Alex O'Connor would postulate that doesn't this mean that it's more of an evidence for like some demigod, so one overall God who doesn't want there to be life and makes it incredibly unlikely to those huge probabilities that you've given us, and then there's some sort of other demigod who wants to go against that and sort of hit the one little note. What would your response be to that sort of argument?
Yeah, I like Alex O'Connor. He's a bit of a philosophical hero of mine, I'd say. I'm not very strong in that area, so I lean on him a lot. Disagree with him a lot, but also lean on him a lot. I would agree with him on that. I think, okay, here's how I would frame that if I was like talking to someone who was not scientifically initiated. Imagine your sister asks you to like babysit their kid. So you're going to babysit your niece or your nephew. And they bring their kid over, and in your house, only one corner of one room is like really suited to like be suitable like to take care of a child, and the rest of the house has razor blades and lava and all types of things that would kill your kid instantly if it got anywhere near it. That's kind of how I see the fine tuning of the universe. I think that's probably how Alex would see it as well. Everything is so chaotic. Everything is so kind of like everything is so inhospitable to life, to the very life that it's claiming to be fine-tuned for, that it's very difficult for me to accept that an all-powerful creator would balance things like that. Someone would like control over space-time and all the elements, could very easily make the entire universe breathable. It would be like he's not confined by these physical laws that we are confined by, and so oxygen could very easily be everywhere. Interstellar travel could have become possible. I just think there's no like physical evidence, or I don't want to say physical evidence. That's not the right word. There's no indicator, in my opinion, that the universe being balanced on a knife edge is anything else other than an indication that things did happen naturalistically. I think actually that's one of the that's a better argument for a naturalistic explanation than the thing that I brought up. Is that I don't think an all-powerful God would want its precious creation to live in a volcano, pretty much.
Maybe you can respond to those, Matt.
Yeah, I think this is an interesting question, and it definitely is something to think about. I would contest the kind of analogy of a child in a room surrounded by danger, because it's in our universe where the laws and constants have the values that they do. We're fine. We see structure all around us. We see lots of elements and chemicals and different types of atoms, and so we live in an absolutely fine universe. In fact, like if there were breathable oxygen anywhere, then you would have too much matter, and you would end up with problems like the universe all crunching together again under the force of gravity. So I think we live in a pretty nicely designed universe. As for why God would choose to create in this way, I think we can't know exactly for sure. I guess it's not as if he's risking anything by doing this. If we believe in a supernatural creator, he chose to create in this way. And I think, I think it's completely, it's a much better explanation to say that God would choose to create in this way. Maybe one reason would be so that this argument is possible, so that we are able to look out in the world and see how unlikely it is that we're in this type of world. And I think another potential problem with this is that it seems like we could say, the universe is too fine-tuned. God has designed it too precisely. This isn't what we would expect. But I think going back to what I said about John 3:16 written in the sky, we could say that and see that and be like, oh, wow, this is, he could have done more. He could have made all of the surrounding universes hospitable, and God could have written multiple verses of John chapter 3 in the sky. But I think that just because there are these possibilities, maybe that would have made it more compelling. I don't think that undermines how compelling the argument is in and of itself.
James, do you mind if I
go
quickly a little bit? I don't want to have another discussion session, and I would love for Matt to respond to this as well if you permit him time. But I have a question. So we can only analyze God's creation through a human lens, through human psychology, and we can say things appear to be balanced on a knife's edge. You would agree with that, Matt?
Yeah.
Okay. So, I mean, I'm sure you've written your fair share of code. You would not engineer any complex or non-complex system in regards to programming on a knife edge like that. You would always include some sort of redundancy occurrences. And so
yes.
I guess my question is, if we as human engineers would not apply the same design principles to our less complex designs, which is, like large language models, which is what I build, why would we as humans, less powerful, less wise engineers build in redundancies and to protect our system and to protect the code within it, but the all-powerful God, you think, would not, and things would be so fragile?
So I think the reason, at least it seems to me, for that is when I'm creating some very poorly written code, the reason why I include so many safeguards is because I know that it's going to be poorly written code. I know that I'm fallible. I know that I easily make mistakes, especially like when I get tired or I'm looking at the screen for too long, and stuff will go wrong. But then when we extrapolate that up to God, he doesn't make mistakes. He doesn't have a need for redundancies because he doesn't get things wrong. And I think that is a danger of this type of reasoning, of just going from what are we like and then trying to expand it bigger, and that gives us an idea of what God's like. I think we shouldn't work that way, and I think that was part of the reason why I tried to use the Bible to justify the reason why God would choose to fine-tune the universe for life, because I think that the best way that we can learn about God is through him revealing himself to us. That's actually, accurate. If he's beyond what we can understand, then we should look to the ways he's revealed himself rather than trying to deduce the way he would reason through things based on the way we act.
Yeah, absolutely. I appreciate that. I'll
No
message you
worries.
offline about, like, I have a further continuation to that conversation. It's more technical, but I'll message you on WhatsApp.
Sounds good.
I'm looking forward to hearing what the outcome of that is. A question we have on the VVox is, so Cedric, are you suggesting a multiverse? I think this was typed before the topic of multiverses came up, and I know both of you didn't mention that in your, well, neither of you ended up mentioning that in your initial statements, but Cedric, later you said that maybe this would be less improbable than a creator God. Would you say that this is a better explanation than a creator God? And in a sense, are you still holding on to this explanation of a multiverse?
Yeah, I think better and more probable. I'm not sure they're interchangeable. I think I expressed my position pretty well, and I think Matt kind of understood, because the multiverse theory is grounded in actual science, empirical science, no matter how wonky the science is. I think that's what makes it more likely, and that's why we could assign it a higher prior. In regards to Bayes' theorem, I don't think I'm not an advocator for the multiverse theorem. I think it's kind of silly. And overall, I would think that something else would probably, like, if we do find a naturalistic explanation for it, I do not think the multiverse theory will be it. I was only propping that up in comparison to a supernatural deity. And even then, I think the probabilities are probably like very similar to each other. I think I said earlier it would just be slightly greater in my opinion.
So you think it's like not a good answer, just
No,
a
no.
supernatural deity, an even worse answer?
Yeah, one, it's a pretty wonky theory, and it's why I didn't include it. And I think it's probably why also Matt kind of skipped past it, because maybe he had enough faith in me not to grasp at scrawls and bring it up. But I don't think I don't think it's a very solid answer to the question at hand: is the universe fine-tuned for life?
Yeah, I would agree. I would just, sorry, were you going to say something, James? I would just I would agree that I don't think the multiverse is a very good explanation, and I think there are arguments against it that we didn't go through here, but I think there are good reasons to reject it. And the other thing I was just going to say is, you said it's based on empirically verified science, which I think is slightly a stretch too far. There are like empirically verified there's empirically verified science, and there's inflation, which is kind of it seems like we have good reason to think that inflation might be true based on the cosmic microwave background, but even that's a bit tenuous. And then multiverses are kind of based on different theories of inflation that kind of come out of nowhere, and along with string theory, which hasn't made any predictions or been confirmed yet. So I would say there might be some tendency to use scientific language, but I wouldn't say that it was at least there's no one unified, one clear scientific theory. It feels like lots of physicists have their own different models that they prefer, but I don't think one of those is, and any of them are particularly scientific theories.
I'm going to get on to asking Matt a question in a moment, but another one for you quickly, Sid. Would you say that you don't think we have an explanation for the fine-tuning or a naturalistic explanation for the fine-tuning of the universe at this stage, but you think that sometime in the future we will find an explanation? Would that be a fair representation of sort of some of your arguments?
Yeah, absolutely. I think it's by far the most compelling argument for God. It doesn't argue for a specific God, but I think one of the Abrahamic faiths would probably be attributed credit if that was to prove that a creator existed. Um, I do think that in the future we are I have enough faith in the scientific method and our, human tenacity to figure out tough questions. We've always done it, and I believe that we will continue to do it. And this is it's not even the toughest question I think we're handling right now, but it is one of the tougher ones. And I believe that we will get there eventually. We're just not there right now. I gave a few examples earlier of how throughout our history, we've we've struggled to answer really tough questions given our capabilities at the time. Ptolemy had no way of knowing that the Earth wasn't the center of the universe. There were no telescopes. He just looked up and it looked like things was circling around us. So that's why he had that opinion. And I think right now we're looking at things and it just seems like they're fine-tuned. And because we don't have the telescope to disprove it, that's the argument we're going with. But I think it's a decent likelihood that we, in the future, as humans, will develop a science that can answer these questions.
Connected with that, so we spoke about sort of this God of the gaps idea and not being able to explain things, and then over time things becoming more explainable. Matt, would you say that this, as a physicist, or maybe this is not your speciality, but would you say that this is a problem that we are getting closer to finding a naturalistic explanation, or is this getting worse or changing in any way, or what's the sort of direction that this field is moving?
Yeah, I mean, this is also not my expertise, but my understanding from the reading I've been doing, well, I think one thing that's important to clarify is that this is a very different kind of question. It's not a question about like, why does lightning happen? But if we ask the question of, are the physical laws and constants of the universe the way we'd expect them to be? This isn't really a question that has a natural answer. Either the answer can be yes, they are what we would expect them to be, or the answer can be no. And currently the answer is no. And so that's not a question that science is ever going to be able to if the answer is no, and the answer is always no, then that's not something science is ever going to be able to answer, because we're asking a question of science itself, a question of the scientific theories, whether they're natural. And so in that sense, I think that Cedric's science of the gaps might like work. It might succeed in giving the answer no, that or sorry, yes, that the answer that the universe and the physical laws are what we expect. But that's, to me, it seems blind faith against the evidence that we've seen over the past 40 years, I think, of investigating fine-tuning, and the problem has become the problem hasn't got better.
Another question, Matt. Some people would say, well, even if you just postulate that there is an explanation for this design of there being a designer, you still haven't answered the question, who designed the designer? And yeah, I know Richard Dawkins has brought up this sort of question. How would you answer that? You haven't got rid of the problem. You've just made it a bigger problem that you have more to explain now. If you're saying there's a designer, that's even more complex. How do you explain that?
That is an interesting objection. Well, my first thought would be, we're talking specifically about fine-tuning here, not about, say, like a first cause. And God doesn't seem to be fine-tuned. It seems like you can describe God as like a maximally great being or perfect. Like, it seems like you can describe God. I mean, the doctrine of divine simplicity seems to get across the idea that God is incredibly simple. And so there's not any kind of fine-tuning going on there. And as an aside of the question of do we need a design? Do we need a designer for every designer that we have? I read an interesting analogy in the research I was doing for this. And the question was, everything that we see around us, when we pick it up, it falls down. So the question is, why isn't everything constantly falling? And so one thing that we could say is that every object that we see around us is just resting on something else. So I'm resting on my chair, and my chair is resting on the floor, and that's resting on the floor of the building below. And it's all just resting on things, and that goes down eternally. It goes down endlessly. That's one possible explanation, but that doesn't seem very satisfying. We have to say that there's an infinite number of things that I'm resting on. Another explanation would be that there's something just for some reason floating in the middle of nowhere that doesn't fall down. It's different, and that again seems a bit random, that there's some strange thing that is doesn't fall. It's just got some special property. Or there could be something that's like falling in on itself. Which is what we have with the Earth. That's what's happening in reality. The Earth is self-falling. The core crushes itself and is supported by itself. And in the same way, when we ask who was the designer, we can say we have designers going back eternally, or we can cut off at some random point and say, oh, well, the universe doesn't need a designer. or we can say that there is some self-existing thing, something that doesn't need a designer. It just is a necessary being. And I think that God fits the categories for this type of being very well. And so that's what we should, that's where we should ground out our causation or our designing. So hopefully those two thoughts somewhat answer the question.
Thanks, Matt. One question that's come up on the VVox for you, Cedric, is, Cedric, are you aware of the objective system of the Catholic Church for determining if a miracle has happened or not? I guess partly a comment, partly a question, but if you have any comments on that, go for it.
No, I know nothing about the Catholic Church.
I know Matt isn't a Catholic either, but yeah, it might be something worth looking into.
I've never heard of this.
Yeah. I would also like to point out that I agree with, well, I don't necessarily agree with Matt, but I agree with the premise of the question, and asking where God came from is dubious. And it's an anti-intellectual argument. So we're together on that.
Fair, that's cool.
Nice.
There's some agreement, great. Another question, why does a God have to follow our human standards? I'm not sure exactly what that's referring to, but one of you might know.
I think probably the, well, I don't know when that question came in, but it may be referring to my comparison of human code to the design of the cosmos. And the answer to that question would be, I don't think he would have to follow our human capabilities at all. I just think that we are made in God's image. And so I would assume that in regards to reason, I mean, and we kind of have an idea of how God thinks as well. I mean, what is the Bible if not kind of like a glimpse into God's mind? Not even just the Bible, but the Quran or any other religious text is a glimpse into the mind of God or gods, depending on if it's polytheism or not. And you can kind of see how they think. And I do think that if a God will, if the God of the Bible was all powerful, it would probably not build things in a way. Actually, you know, I'm not wholly sure I believe that. I'm like changing my mind on the spot. So I'm thinking about stories in the Bible where God clearly does things that I would not do myself. So yeah, I'm not gonna go with that answer because it wouldn't be intellectually honest. I don't really have an answer for that right now. But if someone wants to get me offline, whoever asks that, I would do some research and definitely answer it.
That's cool. Thanks, Ed. Another question from the VVox. Matt, would you say that God is outside of time as an answer for who created the creator? I know neither of you see that as an issue, but some people would.
This is not at all what I've done research on for this debate. So this might be a really stupid answer. I personally think that God is outside of time. I don't know that that necessarily makes a difference to the question of who created the creator. I don't think that actually solves anything. You can even if God is outside of time, you can still like maybe numbers are outside of time, and we can still maybe say who created numbers. Well, maybe you can't. Maybe they're necessary. I don't know. I just don't know that that necessarily plays into the question.
I think, if I may, I think a large part of why a lot of scientists or computer scientists, I won't claim to be like a natural scientist, are turned off by arguments like the fine tuning or like even a Kalam is because of questions such as that. Because when you're using something like Bayes' theorem, like to assert, like to assess the probability distribution of a claim, we have no experience of dealing with something that's outside of space and time. Like we have no experience with that. So how can we properly like assess something such as that? And so I think is like stating that God is outside of time and space and therefore like immune to the laws that we abide by is equivalent. I think it's kind of as dubious to the atheist saying, well, if God created the universe, then who created God? It's kind of a cop-out. Like, how do you respond to that? And then from a scientific or statistical perspective, like, how do you test that? Like, if your God who created everything is outside of the universe, then every single, in regards to like the priors that we're talking about, every single prior is going to be near zero, if not zero, because we have no evidence of that. We've never been able to observe that. And I know Matt doesn't like the idea of asserting priors based on what's observable or not. But that's kind of what we do. We figure out what's happened, how often it's happened, and then that's what we set the prior to. And because we have no experience with something, with an entity that's outside of space and time, and also no evidence that this entity actually exists, then it's nearly impossible to use any type of scientific reasoning to argue for it, in my opinion. And so I would just caution whoever asks that question to against maybe like reframe it. But I don't think it's the best way to engage with someone who's on the fence regarding this argument.
Another question, following dimensional research, isn't it possible for a God to just be a being from a higher dimension?
Yes. I talk to my friends about this all the time, actually. I have a friend named Tevin, and we're like, we constantly speak about, like, if there is a creator, how we could probably come around to believing that it's a creator, like, because of how fine-tuned things appear to be, but how we probably wouldn't call that creator a god, and how it probably wouldn't be anything from any of their religions. And that's usually what we come to, is that it would probably be some sort of like supreme higher intelligence outside of our understanding, but maybe not this all-powerful personal entity that the Abrahamic faiths referred to.
So with regards to dimensions, I think again, this is not my field, but my understanding is that so string theory posits that we have like 11 dimensions, but when it posits those extra dimensions, they aren't it's not that we're in a three-dimensional world, kind of say like a sheet of paper sat on the table of a three-dimensional world. We're not a three-dimensional world sat on the table of a four-dimensional world. In fact, it's almost the opposite, that these extra dimensions, these, 7 extra dimensions, because we have 3 space and 1 time, these extra dimensions are actually curled up really small, so small that we don't observe them around us. And so it seems like God isn't going to be in one of those really tiny dimensions, but instead it makes much more sense to me as a physicist, in contrast to what Cedric said, to think that God would be outside of space and time. If space and time are the fabric of our universe, it seems like they're just parts of the universe, especially with Einstein's understanding of relativity, and space and time being the fabric of the universe. It seems to me very plausible that God would therefore be sitting outside of that. He wouldn't be included in this fabric. He would be the one who's set it up, which makes him supernatural. But I don't think it is fair for us to rule out the supernatural without at least having some good reasons to first.
I agree with
We
that.
will be wrapping up in a couple of minutes. Maybe a last 2 questions. One is, Cedric, the idea of the Occam's razor and just inference to the simplest explanation, and some people would argue that that's a good reason to say that a designer is just the best explanation here and anything else is more complicated. What would your thoughts be about that?
Yeah, I think that ties into my last answer. I don't think when you're asserting that you have beings outside the fabric of space and time, I don't understand how that could be the simplest explanation. Matt and I will disagree on this, but how can it be the simplest when we have no understanding of that? We have no experience or way of even testing to see if it's even possible, as to where he disagreed with me earlier, but I do think that the multiverse theory is at least grounded in already pre-existing scientific hypothesis, which is why I believe it's much more likely. But yeah, I don't think in this. I do think that the simplest explanation is usually the best, but I just don't think that the creator hypothesis is the simplest for this, simply because of what that creator entails, and we have no way of testing it.
Can I ask a question?
Yeah, absolutely.
Do you think that there's anything other than like the material? Because to me, if there's like stuff like numbers or the mind or it's some kind of moral law, to me it seems like, or anything supernatural, it seems like there's there's got to be something more than just the physical world, but maybe you disagree.
Yeah, I do disagree. I do understand what you're getting at. I don't believe in like moral law, or like objective morality, which may like throw some people off, but I'm happy to explain it if maybe anyone wants to reach out. I just think that numbers are, abstract entities that we use to understand the world around us. I think that morality is subjective, and I think that there's a difference between using an abstract idea to create something such as mathematics is different than asserting that there is an entire being outside of the fabric of space-time, that created everything. So yeah, I think that would be my answer there.
I think that will be a topic for another whole debate at some point.
Absolutely.
Which it will be exciting. Final question for each of you to comment on maybe. Earlier in the debate you said, I have enough faith in the scientific method that there will sort of be an answer or something in the future, which is an interesting statement. I think both Matt and I smiled at the time in terms of, I know the audience can't see the others' reactions because there's only one person on screen at a time, but we've all been smiling a lot. So my question is this question, is the universe fine-tuned for life? Is this a question of science? Or are we going to have to go outside of the realm of science here? Maybe each of you could comment and then we'll close.
Yeah, I think it's a scientific question. I think Matt gave a fantastic presentation in the beginning. I didn't understand all of it, but the 75% of it I did understand made perfect sense. And he explained very perfectly why he believes, well, why the universe does appear to be tuned for life. I don't think you can really answer that question or convey like your opinion on that question without invoking some sort of scientific jargon. And I don't think we'll be able to answer it yes or no without the scientific method. I know Matt disagrees with that, but I don't see it as really answering the question per se, which sounds strange. I see it as science will get to a point to where perhaps we can convey why these particle masses are what they are, why these constants are what they are. Could they have been anything different? And so on and so on. And as we get there, then these questions will start to kind of answer themselves. But of course, science can't answer just that question, but it can provide us with the data to come up with answers ourselves.
Actually, I don't know. I think I'd like to end it on a point of agreement. I think that the question of whether the universe is fine-tuned for life is a very scientific question. I think that the best way that we can answer it is by plugging different values into our scientific models and see, which is very easy to do, and seeing what happens. But I think that the question of what we do once we find out that actually the universe is incredibly fine-tuned for life, how we respond to that takes us outside the realm of science. And maybe Cedric is right that one day science will no longer give the answer that the universe is fine-tuned for life. But at least now, while it's been saying for a long time that yes, the universe is fine-tuned for life, I think we should be trying to answer it as best as we can.
There you have it. Good note of agreement to end on. Thank you so much to Cedric Paige and Matthew King for joining. Thank you for your time preparing. And thank you for everyone who's contributed through questions and listened. And well done if you have lasted all the way through our 2 hours. It has flown by. And yeah, hopefully see you again